Hello there. My name is Trac Bannon, and I'm very excited to be here today. Thank you to Mike Schmoyer and to the Digital Government Institute for inviting me. Today, we're going to talk about different ways to leverage AI models to improve software creation with low-code and no-code platforms. Let me introduce myself. My name is Tracy Bannon. I go by Trace. I'm a senior principal with the MITRE Corporation. My background includes a couple of decades as a software architect and engineer. My passion as an architect is applying architectural thinking across the entire digital ecosystem. Let's get started with a common definition of low code, no code. Both are intended to accelerate development by providing a visual interface and a lot of pre-built components, and both provide drag and drop functionality. There are two primary differences. First, target audience and expertise. No code is assuming non-technical users and provides the greatest amount of simplicity and ease of use. Low-code platforms are designed for users with some degree of technical expertise, such as developers who want to be able to create applications more effectively and efficiently. They're geared towards enabling people to have more control through some customizations and some extensibility. No-code platforms prioritize simplicity. They prioritize ease of use. And as a result, they do have some limited customization options. Low-code platforms generally offer a higher degree of customization and flexibility. Some would argue that this makes low-code platforms more suitable for more complex, tailored application. I've added the names of a couple of vendor platforms under each column. These are for informational purposes only, and please do not consider this to be any sort of endorsement. Let's also revisit the benefits of low-code, no-code. Briefly, rapid development means faster prototyping and faster time to market. There's a lower barrier to entry, and that empowers non-technical staff to contribute to development. It also reduces the reliance on specialized developers. There can be a cost savings with reduced development time, and sometimes there are scalable pricing models. Collaboration can be enabled, especially when there's real-time feedback with the users. Built-in security features and best practices help to standardize security compliance. You can have adherence to different governmental regulations, for example, such as FedRAMP and NIST. Generally, these platforms come with many accessible learning resources and a vendor-provided ecosystem for support and maintenance. We can all probably agree that there are definite use cases where low-code and no-code platforms are really valuable. Unless you've been completely air-gapped during your professional and personal life, you're probably well aware of the wave of artificial intelligence, innovation, generating art videos, marketing emails, social tweets, all impacted by AI. The same is true of software development. This is actually not new, but it's very much at the forefront and it's accelerating rapidly. So let's get a couple of definitions about artificial intelligence laid flat. Generative AI, including large language models or LLMs, focus on creating new content or patterns by learning from existing data. Large language models are trained on extensive text data, enabling them to be statistically predictive of words and sentences and then generate human-like text. These models can be utilized in AI-assisted development to enhance the developer productivity and streamline software. There are myriad low-code and no-code platforms available in the market. The features and capabilities they provide vary wildly as well. For that reason, each one of the platforms is applying generative AI in very different ways. It would take us a full day to deep dive into each one of these concept areas. I want you to walk away understanding the many different ways generative AI is improving low-code and no-code experiences. Generative AI can be used to create custom applications based on natural language descriptions or templates, simplifying the development process. OutSystems, in particular, is quite a thought leader in this area. Large language models can generate UI components and layouts based on user requirements, improving the user experience and reducing design time. Generative AI can analyze existing workflows and recommend improvements or automations, streamlining processes and reducing manual effort. LLMs can assist in integrating low-code platforms with existing systems by generating custom connectors and API code to facilitate the integration. Generative AI can create domain-specific languages tailored to specific industries or use cases, simplifying development within the low-code platform for specialized applications. One of the thought leaders in this space is Betty Blocks, though they generally don't sell or deliver in the government domain. And finally, large language models can enable low-code platforms to offer pre-built customizable AI components, allowing developer users to easily incorporate advanced AI capabilities into the app. I do want to expose you to a couple of samples of generative AI in low-code platforms. We'll start with OutSystems. They have a generative feature called Code Mentor. When you're inside the developer's workbench, you can use natural language to manipulate data. For example, if you were writing a hospitality app, I'd simply need to say, bookings whose checkout date is today. You don't need to know SQL language at all, and you can continue to work with and manipulate the data using natural language. Another in-workbench capability is the property or event suggestion mechanism. Code Mentor will make suggestions to you on what your next action should be, and it will guide you through the configuration. This generally offers productivity gains. It's going to reduce onboarding for new developers, those citizen developers. There's some interesting conversation growing in industry around the possibility of dampening innovation or creativity. We'll have to continue to monitor this. The general idea is that you no longer have to think because the options are simply presented to you to select from. It's important to ask your vendor what data they're using to train the suggestions for properties and events. Is it their full customer base? And finally, your organization will still need to have some specialists with technical depth. Let's take a look at another example of generative AI in low-code platforms. This is coincidentally OutSystems. I picked it because it highlights additional architectural maturity that is coming to low-code platforms. The generative feature is called the Maintainability Mentor, and it provides a guided refactoring mechanism. Given that all your code resides inside the low-code platform, the AI algorithm is able to run a code structure analysis and then can pull out and identify places where you'll find both positive and negative or anti-patterns. In the example I have on screen, Maintainability Mentor has crawled the codebase and has highlighted a number of places where there's duplicate code among the other types of patterns that it can detect. Digging deeper into the duplicate code, I can see that there are 3 specific components essentially identical. This is often a situation that's cited by traditional software development and delivery organizations: waste in the codebase. Maintainability Mentor will even guide you through how to fix and refactor. Applying structured code analysis to low-code and no-code is a tremendous improvement, but it does bring up a few questions. What code is being used to train the model? More importantly, who should be executing the refactoring? Often platforms are used and shared by many, many different delivery teams. What's the scope for making the changes? Who has the authority and skill to be able to make those refactoring decisions? And of course, how is it going to be tested? The next example is from Microsoft. It's Power Automate. The generative feature is their AI builder. As a developer directly from my workbench, there are turnkey models available to me to embed, which are pre-trained. I can also take those models and further customize them, providing enhanced capabilities to the end users. There are a couple of considerations to keep in mind. You'll need to find out if there is an additional cost for using the models, and there could also be possible performance hits. Models need storage, models need compute. Generally, those are not free. Again, you'll want to find out whether or not your vendor uses your model and your data. When I customize my model, is this somewhat of an open source model training situation? In general, I recommend practical restraint. When you're embedding your first model, engage and understand the impact on the end users. I want you to ask your platform vendor questions around the security training and management of their models. First, you want to understand the data handling practices and policies of the vendor to make sure that sensitive information is not inadvertently exposed or misused during the model's training and application. Second, we want to ensure that the AI model does not introduce new security vulnerabilities or promote insecure coding practices. This is crucial for maintaining the overall security of the applications built in low-code platforms. Third, proper access management is essential to prevent unauthorized access to the AI models, which could lead to unauthorized modifications, data breaches, data poisoning, or other security risks. And finally, regular updates and security assessments of AI models are necessary to ensure that they continue to provide secure, reliable foundation for low-code developments. You will need to understand how your vendor is going to handle when new vulnerabilities and security risks emerge. As I mentioned before, generative AI is the overarching concept of being able to create new content. Large language models are focused on words and text. When you use low-code platforms, there's an opportunity to create code regardless as to which low-code platform it is. I'd like to spend a little bit more time with you discussing large language models and coding. Developers are automatically generating or completing code snippets, making it easier for them to write code faster and often with fewer bugs. Models are also being used to help review code for style, consistency, and potential bugs. Assisting developers to maintain high-quality code, I'm really excited about the natural language translation. This really is using English language descriptions of functionality to generate code, and this often means non-technical team members can contribute. Generating and maintaining software documentation, keeping it up to date and accurate, and assisting in creating knowledge repositories for future development teams to leverage is also a boom. We're definitely seeing the use of language models to analyze logs, error messages, and even user feedback. And while this is not totally new, it is definitely another area of explosive growth. Delivering personalized learning resources for developers fosters continuous learning, helping stay up to date with the latest technical trends. As an architect, I'm probably the most excited about improvements in code review. If I'm able to train and help more junior staff to be able to do their first round of code reviews, it means that we'll be able to better scale and have higher quality all around. That being said, all of this is exciting. The question is, do you know the name of any large language model that's currently popular? Unless you live under a rock, I'm going to make the bold statement that you've probably heard of ChatGPT from OpenAI. Because you're going to hear about this model most frequently, I'm going to give you a little bit of information to take back to your organization. Quick context on ChatGPT. It was released in November, and it is already being used by over 100 million people. It's funded in part by Microsoft, and that opens up a number of ethical questions. It's being used by many different domains, including education, contracting, language arts, as well as generating copy text. And it is spitting out copy text with tremendous literary flair. Now remember that it's a language model, and it's just a language model. It's been trained with vast amounts of text data, and it is calculating the probable distribution of sequences of words. There's a crazy attraction that we all have with ChatGPT right now. You don't have to write in any kind of programming language to interact with it. It responds to natural language. Responses are eerily entertaining. They're oddly educational. If you haven't tried it, then you should. I urge you to create a free account and type in this prompt. Act as a funny, witty dad and write 10 dad jokes about chickens walking into a bar. So while that's fun, let's talk about the real use of ChatGPT to generate code. The exact prompt that I used was, quote, write an open API spec for a CRM API, end quote. I'm showing you a picture of the generated display. It's obviously truncated because it's much too long. You can see that the interface includes a copy button that allows me to take this code and place it directly into my IDE or Workbench. Consider ChatGPT understood what CRM means. It also understood the CRM domain. It also understood HTTP methods. The code that was generated did have some minor syntax errors, but they were easily addressed. I would caution from trying to use ChatGPT to generate unit tests, though. There's very little value compared to the fine-tuned tools that are available from openapis.org. This is one small sample of how language models, specifically ChatGPT, can be used to generate code. It doesn't mean that we're suddenly going to reduce our development staff. It may mean a loss of productivity at first. Prompt engineering, even with natural language, takes some time to grow your skill. Right now, industry is abuzz claiming all sorts of benefits from using ChatGPT with the software development lifecycle. You need to be aware of a couple of the claims to be able to understand and question your software delivery teams as they move past the hype and get better understanding of how this is evolving inside your organization. Faster results only happen over time. Getting used to the new tool takes time. You also need folks to understand when they're spending too much time trying to generate code when they could be writing it themselves. Being mindful of the potential over-reliance on generated code and focusing on higher-level problems. Ensure your developers are maintaining their coding skills and understanding the fundamental principles, even when they're delegating tasks to the platform. Working in unfamiliar domains requires that you realize that there are limitations of AI-generated solutions. They may not always work with the specific domain and the leading practices necessary. It's actually a slippery slope when it comes to learning new programming languages using ChatGPT. We need developers that are able to verify generated code. Translations are not always accurate, though they are getting much better than when ChatGPT was originally used. If you are using ChatGPT to explain a piece of code, it could be inaccurate because ChatGPT does not have the full context or intention of that code snippet in the broader code base. And while I'm really excited about using assisted debugging and code review, don't remove the humans from the loop yet. I love this quote. It's from a professor at the University of Toronto. ChatGPT is very good for coming up with new things that don't follow a predefined script. It's great for being creative, but you can never count on the answer. You see, when you're using ChatGPT, you have the option to regenerate a response. And the way that the algorithm and the service is created, it'll look at your prompt and then it will attempt to generate a completely different response that meets the requirements of your prompt. Go ahead and try it. You can regenerate multiple times in a row and each resulting output will be different. Now, remember, these are language models that are using statistical probability to stitch together sentences, phrases, and programming code. So when it comes to ChatGPT, when it comes to applying alternative generative AI to low-code platforms and to custom development in general, I'm an advocate. And I do believe that we need to be pragmatic. Here's a list of some additional areas that have a surge in innovation applying generative AI to software development. Rapid prototyping, intelligent development assistance, essentially pair programming with you inside your development environment. Code refactoring that we talked about before. There's also a lot of work going on in getting precise estimates for how long development efforts will take. Generative AI is being applied to decision-making, and it's going to make a dramatic difference, a dramatic change in human experience and human factors analysis. I'm usually pretty pragmatic, so I want you to be aware of some gotchas that are on the horizon. Our industry is struggling right now with SBOM, the software bill of materials. This is where you have complete understanding of all of your software dependencies and can trace the lineage. If code is being generated from AI, what's the source for your lineage? Is it the model, or is it the data that was used to feed the model? And whose data was that? In the same way, universities need to be able to detect when assignments are completely generated. We will need to be able to detect when code has been generated. We also have to go in with our eyes wide open, understanding offensive and defensive exploitation. Bad models produce bad outcomes, especially if someone intentionally poisons the model. Especially with code generation, a whole new breed of vulnerability is on the horizon. Look, guys, There's still a lot that we need to understand. We can't put the genie back in the bottle. We need to discuss, research, and understand. Here are a couple of items to keep in mind as you continue to be exposed to and adopt generative AI for software development. Prompt engineering is actually a new discipline. There are plenty of cheat sheets that are available, and you may want to have your own repo of prompts. It's yet to be seen what's going to happen with human-machine teaming. If I'm sitting each day pair programming with a virtual assistant, what's the impact on me as a human? What will happen with software team performance, especially over time? Are we going to cause additional cognitive overload and further burn out teams? Will the pace become too much for our humans who have always been a core part of software development and delivery? As many folks are excited, there are skeptics, and it will take a while for us to have trust in assisted AI and AI-generated software. And finally, we need to understand the ethics of prompts and who owns the data once it's created. That will obviously depend on who's hosting the model, where the model's hosted, and if you have a EULA or licensing agreement. It should either specify or perhaps it noticeably doesn't specify the answers to these questions. This can seem overwhelming, but we need to continue to surface concerns and issues. AI sounds authoritative, and it can be flat out wrong. The data quality and the context of data has a dramatic impact. Quality assurance and the testing of models is a science still being studied. Just like we have access to these tools, so do the threat actors. And in the government space, we have to be aware that models are sometimes trained by non-US citizens. If nefarious actors are able to get after the data used in the models, they can poison it. So I have some more homework for you, a call to action of sorts. Connect with your low-code or no-code platform vendors and ask them about model quality. Ask them the security questions we discussed earlier. Ask your platform vendor about their AI roadmap. You need to pulse your own organization to see if and how language models are being used right now. You want to enable research and development with cybersecurity as your highest priority. Use that information that you pulse, that you gathered, to establish reasonable guardrails for your organization. I also need your help in my role with a federally funded research and development corporation. It's important that I understand your organization's stories and your lessons learned. As you encounter new use cases and new tools, please reach out to me. I'm going to show you my contact information. I'm looking forward to you shooting me an email or connecting with me on LinkedIn. There you go. You can see my contact information there. If you'd enjoyed this content, you might appreciate that I used generative AI to improve the actual slide quality for the graphics and to generate the artwork for the AI face. Thanks again.